Then let's have quick revision for this one topic. Dual nature of radiation and matter. Okay, so first of all, what is this? What is photoelectric emission? Guys, are you all there? Except Pravalika, nobody is answering. Harsha, Saksham, Shelam. You guys there? Can you hear me? You guys can speak, right? And what is photoelectric emission? Emission of free electrons. Simple. Emission of free electrons from surface of metals. When name itself, photo means light. Light radiation falls on it. Simple. In that, what is the threshold frequency? Threshold means minimum frequency. Incident radiation to eject electrons. Which is known as V naught. So when V is less than V naught, there is no photoelectric emission. No photoelectric emission. Then what are other ways of electron emission? What is electron emission? From the name you can say emission of electrons. Electrons. In that we have what? Photoelectric, we saw just now. Then next, fermionic. Fermionic emission. Emission of electron by heating of metal. Heating of metal surface. So where this is used? In television, where picture tubes. Field emission. Simple, like you guys are not answering. Field emission is what? Emission of electrons by a strong electric field. This other name of this one is cold emission. Cold emission is electron or emission of electron by strong electric field. These are the methods of electron emission. What are cathode ray? Anyone? Guys, you're not answering. Okay, fine. Cathode ray are,
negatively raised.
yes, are fast moving electrons. Negative charge electrons, fast moving electrons. Okay, what are the points we can write for this one? Cathode
Moves
ray,
from cathode to anode.
yes, move from cathode to anode. They can be affected by what? Mechanical and magnetic and electric field both. Right? They can be affected by magnetic,
Electric and magnetic.
yes, electric field. They produce what? Something fluorescent.
Produce fluorescent light on zinc sulfide screen, sir.
Yes. So its velocity range is from 1/30th to 1/10th to speed of light. It's 1/10th or 1/30th, its range to the speed of light. It's a range in between is for cathode ray. This was, let's write Milliken's drop experiment. What is Milliken's drop experiment? What was Milliken drop experiment? Anyone? Charge on an oil droplet always at integral multiple of elementary charge, which is 1.602 into 10 to power minus 19 coulomb. V1 plus V2 by V total V and V1 by 2G rho minus sigma 1 by 2. Where V1 and V2, what are V1, V2? Terminal velocities. One is when no field is applied and one where field is applied. Okay, then what else we can have? Yeah, there is most important Einstein of photoelectric equation. Half mv square, and it is maximum sorry h v minus v naught h v minus h naught. Speed h c 1 by lambda minus 1 by lambda naught. H. So that is what hv naught plus k max. This one. K max we can write E V naught by V max equals to 2H V minus V naught by M under root. If we solve this one, we can get V max equals to 2HC by M lambda naught minus lambda by lambda lambda naught under root. And this one we can write as K max HC 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 lambda naught minus lambda by lambda naught. H by E, V minus V naught, HC by E, 1 by lambda minus 1 by lambda naught. I'm just splitting those. HC by E. So this will be a final form. You can remember this. What are photon? They are just tiny particles for light. Light energy equals to HV. If photon is at rest, what will be its mass? It will be rest photon mass will be 0, but effective mass will be E equals to mc square, which he derived, equals to hv. So m equals to E by c square equals to hv by c square. H by c lambda. So this is known as kinetic mass of photon. If you want to find momentum, we can add like P equals to mc. Now substitute remaining thing here. Use this and substitute there. T by C or HV by C or H by lambda. Sorry, H by lambda, whatever. Photocell. What is photocell? Anyone? What is photocell? Converts a change in intensity. illumination, brightness or illuminating intensity of illumination into photocurrent. So we are using this photocell in photoelectric effect. Uses as a counter, like count a person which has entered in auditorium or a television or burglar alarm. So many places we can use it. I'm not writing uses, you know those. So in this one, potential photo current, electric current will become 0 at a particular value, at some standard value, which is known as V0. That is cutoff potential or stopping potential or whatever. So, sorry. So there varies with what? Frequency. So they varies with frequency. Frequency of incident radiation. Let's talk about X-rays. Its wavelength range from 0.1 Armstrong to 100 Armstrong. Another point we can write about X-rays are, any other points? Wavelength is 0.1 Armstrong to 100 Armstrong. Guys, any other points? Come on. If you don't answer, like, I'll get bored. Come on, answer it. Come on. Any other points for X-rays? Yes, guys. Any other points for X-rays? Speak up, guys. Shall I say, or you want to answer it? Okay, wavelength, its range is 0.1 Armstrong to 100 Armstrong. You know conversion of Armstrong, right? 1 Armstrong equals to 10 to the power minus 10 meters. This you all know, right? Okay, very good. It has high energy. What happens which has high energy? It emits what? Fast moving electrons. Okay, and remember what we studied before? Cathode ray. It also fast moving electrons.
So these rays doesn't deflect by electric and magnetic field.
Yes, there is a difference. Exactly. These are also a fast moving electrons. Okay, they strike a target like which has high atomic mass, but it doesn't get affected as cathode ray. when strike target. Application. In like medicine and surgery, radiotherapy, so many things, right? Radiotherapy, surgery, medicine, like to find some internal structure of material or crystal. What are properties? We can see they are invisible. Second one, this travel straight line in a speed of light. X-rays are measured in. This is also important. Anyone remember name? Drawing 10. Drawing tangent. They are measured in drawing tangent. And as we said, as he said just now, he's not getting affected by magnetic and electric field. Why? What's the reason? What's the reason behind this? Why they are not getting affected by electric and magnetic field?
Electrons move faster, sir.
Electron move faster. It is in cathode ray also. It's also fast moving electrons. Then there's one special condition here. It carries no current or no charge. So they are not deflected. It does not carry charge. So they are not deflected by magnetic and electric field. Next, the ionized gas. The most important, do not pass through bones and heavy metal. So we are using this to scanning our bone. And even long exposure to X-ray will injury. For us, it's not good. Now, if you remember, lead is of X-rays. So in that, for scanning our bones or body parts or X-ray photography, of human body, BaSO4 is best absorber. So as we say here, it's traveling speed of light in a straight line. So they follow all the laws of reflection, or they show like same properties like reflection, interference, diffraction, polarization, and what are things? So all other things. Okay. Absorption of X-rays. So absorption of X-rays when they get incident to any substance. Okay. So intensity will be equals to I naught e to power minus mu x. So in this is intense or emergent ray, this intensity of their X-rays, but intensity of absorbed X-ray I dash can be I naught minus I. So what is X? What is X here? Thickness. And mu coefficient. Whose coefficient? Absorption. Absorption coefficient. Another important that is matter wave, or other name is de Broglie wave. You have heard of this one so many times, you've done so many times, right? It's so important also. De Broglie waves. Okay, what are these? What are these waves? These are what? Wave related to one moving particle. Simple. They are associated with moving particle when it propagates. Okay, with the group. Simple. So de Broglie wavelength de Broglie wavelength lambda equals to h by p h mv momentum. So h equals to 2 me. So lambda is proportional to 1 by p, proportional to 1 by v, proportional to 1 by e. Okay, what are the characteristics of these people? Yes, guys, tell me. Anyone? No one. Okay. Simple. See, this magnetic this matter waves are not electromagnetic waves. Okay, they are not electromagnetic. They are not electromagnetic wave. So they are independent of charge particles. So this, if you have been into your lab or a microscope, so electron microscope works on de Broglie wave or matter wave. So this velocity can be greater than speed of light. You know speed of light, right? So it's a matter wave. It can propagate to this vacuum also. That's not to mention. Let's do some exam question with this. What are types of photo cells? Photoemissive cells, photoconductive cells, photovoltaic cells. Let's do some random questions. Previous years. Okay, let's start with this one. A 200-watt sodium lamp emits yellow light of wavelength 0.6 micrometer, assuming it to be 25% efficient converting sorry, electrical energy to light. The number of photons of yellow light emits second is it was from 2012. One 1.5 into 10 to power 20, B 6 into 10 to power 18, C 62 into 10 to power 20, D 3 into 10 to power 19. What they give here? It's this lamp 25% and this lambda it's given, right? Let's solve this. See, only 25% of 200 watt convert to yellow. That is what it's happening here. 25.06.6. Okay. So formula HC by lambda into N, which is equals to 200 into 25 by 100. So what is N here? Number of photons per second. H is Planck's constant. C is speed of light. Solve it. Find out N. 225 by 100 into lambda is how much? 0.6 into power 6. So 200 into 25 by 6. Sorry, 100 into 0.6 into 10 to power minus 6 divided by 3 into 10 to power 8 and H value 6.2 into 10 to power minus 24. 34. Sorry. Minus 34. So plus 8, 32, 26 minus 620. So it should be 10 to power 20. So is there anyone 20? Yeah, we have two options as 20. Okay. So multiply this. $25. Okay. So here option should be 1.5. Check it. Is it coming same? Is it 1.5 10 to the power 20? What's your answer? I just did orally. Tell me, is it correct? Or 62 into 10 to the power 80? 20. $1.5. Okay. What about others? Same answer? Shall we go next question? So let's do this 2018 question. Two electrons are moving with speed perpendicular to each other if the corresponding de Broglie wavelength are λ1 and λ2. The de Broglie wavelength in a frame of reference attached to their center of mass is option A, lambda cm equals to λ1 equals to λ2. Okay, let's see. B, 1 by λ1 equals to 1 by λ plus 1 by λ2. I mean, this is Cm. Lambda Cm equals to 2 λ1 λ2 by λ1 square by λ2 square. Let's see here. B and C might be possible. Third one, lambda Cm equals to lambda 1 plus lambda 2 by 2. Are you doing? Shall I solve? Okay, then let me solve. So if you want to find momentum, what we'll do here for the value given, open each other, the corresponding de Broglie wavelength of lambda 1 and lambda 2. So h by lambda 1 and h by lambda 2, two things, right? So velocity at the center. We need velocity at center. So Vcm equals to lambda by mass 2m lambda 1 center plus lambda by 2m lambda 2. I j because P equals to mv, this we know. Divide by 2, right? Center means attached to the center of mass. Okay. So from this one we can find lambda Cm equals to this divided by this is h. This cannot be lambda. I'm sorry. H. Lambda Cm means this divided by okay. H divided by under root of h square by 2m lambda 1 square plus h square square, no? So it will be 4. I'm converting this one into 4 lambda 2 square, which will be equals to 2 outside lambda 1 and lambda 2 H outside and one H will be okay. Outside because okay. But this one I'm getting this one. So if you don't get confused with this, what I'm doing. Okay, so it will be 2 reciprocal of lambda 1 lambda 2 by lambda 1 square by lambda 2 square, which is in under root. Even last year, so they asked one question from this. Okay, let's do last year question. Okay, which option by the way? Option C. Are you all able to understand, right? You all there? Can you hear me? Guys, are you all there? This was asked in exam. E is given as 10 to power 3 cos theta. Not cos theta, wait. 2 pi x by 5 into 10 to power minus 7 minus 2 pi 6 into 10 to power 14 t x Newton per coulomb. So this light falls on metal plate of function 2 electron volt. The potential of electron is E is in, it is given in EV, okay, electron volt, which is 12375 divided by lambda. This is in Armstrong unit. This is in EV. So options are A 2 voltage, B 0.72 voltage, C 0.48 voltage, D 2.48 voltage. Now, by the way, what is this thing? 2 pi and 6 to power 16 to the power 14. That is omega. And in omega, we have 2 pi f. That means frequency is 16 to the power 14. So if we solve, omega is 2 pi 16 to the power 14. 6 into 10 to the power 14. So frequency is 6 into 10 to the power 14. So wavelength lambda equals to C by F. 3 into 10 to the power 8 divided by 6 into 10 to the power 14, which is 0.5 into 10 to the power minus 10. Okay, see, I need in Armstrong. They have given as lambda in Armstrong. So what we have to do? We have to convert this into 10 to the power 10. No, this is not 10 to the power 10. It's 6, 4, 6. So I need to convert this into Armstrong. So what I'll do? I'll give 5,000 here, means 4 zeros. That means 10 to the power minus 10 Armstrong. This can be written as Armstrong. So final answer is 5,000 Armstrong lambda. Now E is 12375. This is in EV divided by 5,000, which is 2.48 EV. It is 2.48. Okay, don't take D here. It is in EV. So E equals to W plus EV. So 2.48 equals to 2 plus EV S. So if we subtract this one, Vs will get 0.48 voltage. So we have yes, CS 0.48. Okay. So what we have to look after? See, directly if we have done, then we won't get, we will get answer as 2.48. But they have said it is in EV, electron volt. So we need to convert this one. Work function was given as 2. So we subtracted from that. So remaining 0.48 voltage. Clear, everyone? Is there anyone having doubt? Okay. No answer. Shall I stop sharing? Let's meet tomorrow. I'll post the timing for that according to other